Okay, so we're going to be going over division of decimals, where the divisor is a whole number. So we'll go over what that means in just one moment. So before we start, we're going to go over just a little bit of vocabulary check for you guys. So first, I just want to point out that this number sentence is the same as this. So those are the same thing. And now we're going to go over vocabulary. So first we're going to talk about our dividend. Our dividend is what is being divided. So on the left, we see that it's a 17.1. And in the example on the right, we see it's also 17.1. It's important to notice that when it's written these two different ways, the order changes. So make sure you're being careful about where you are putting your dividend and divisor. So now that we know that that's the dividend, we're going to talk about which one's the divisor. It'll be the other one, so the 9. So the divisor is what you are dividing the dividend by. So in this example, we're splitting up 17.1 into 9 groups. So that's going to be our divisor is 9. And last but not least, we have our quotient. Our quotient is going to be the answer to a division problem. The quotient is the answer. So throughout this, we're going to try and make sure we're using our precise vocabulary when we talk about division. So for our first example, we're going to do this 17.1 divided by 9. So I'm going to break it down digit by digit. So when you look at your numbers, we're first going to start with the first digit. I'm going to say, does 9 go into 1? If so, how many times can it go into 1 without going over? The answer to that question is 9 cannot go into 1 any amount of times without going over. Then I'm going to look from 1 digit to 2. So I'm going to look at 17. Can 9 go into 17 any number of times without going over? The answer to that is yes. 9 can go into 17 2 times. So from there, 9 can go into 17 1 time. See, even I make mistakes. So from there, we're going to take 1 times 9, and that gives us 9. Then we're going to subtract 9 from 17, and we get 8. After that, we're going to bring down the next digit. So we're going to bring down the 1. So now we have 81. So we're going to try and continue our division on down the line. So we're going to look at it, we're going to ask ourselves that same question. How many times can 9 go into 81 without going over? Think about it. 9 times. 9 can go into 81 9 times. So we do 9 times 9, and that gives us 81. We're going to subtract 81 from 81, which gives us 0. We know we can stop bringing down numbers and end our division problem once all the numbers at the end of our dividend are 0, and when we subtract, we get 0 at the end. So we need to have both of those conditions to be done. So at this, we're almost done, but we have one more thing we need to check, the decimal point. In division, we bring the decimal point straight up. So we're going to move it straight up into our quotient. So our final answer for this is 1.9. If you want to check our answer and we're unsure if we got the correct thing, we can do 1.9 times 9. And that can be how we check our answer. So we'll see 9 times 9 is 81, carry the 8. 9 times 1 is 9, plus 8 is 17. This is a good review of our multiplication with decimals. So we move the decimal out 1 place in the top. So we're going to need to move it back 1 in the answer. So 17.1. And see, then we know that we did our problem correctly. So that is a good way to check your answer. So now I'm going to give you time to pause this video and try it by yourself. When you do that, just remember at the last step, don't forget, move up your decimal. All right, I'll pause it. You guys can pause it now so you can do this work, and then we'll go over it together after you're done. So just press play once you're done. Okay, so we're gonna look at this problem. So the first question I'm gonna ask myself is, how many times can 13 go into 27? Think about it. 2. 13 go into 27 2 times. So I'll put that up above the last digit I was working with, the 7. And then I'm going to say 13 times 2 gives me what? 26. And I'm going to subtract that total from 27. So 26, 7 minus 26 is 1. And I'm going to bring down the 4. I'm going to ask myself that same question. How many times can 13 go into 14 without going over? The answer to that is 1. So now I'm going to do 1 times 13, and I get 13. I'll repeat that subtraction. 14 minus 13 is 1. I still have more numbers in my dividend that I haven't dealt with, so I'm going to have to bring down the next one. I bring down the 3. Then I ask myself again, how many times can 13 go into 13 without going over? It can go in 1 time. So 13 minus 13 gives us 0. So now we look. We have 0 after we subtract, and we have no more numbers in our dividend to deal with. So we're done with the long division part, and now we just need to make sure we have our decimal in the right place. So like we said, in division, we want to move our decimal up. So we're going to move it right up there. So our final answer for this problem is 2 11/100. So if you didn't get that answer, try and review this problem one more time and see if you can get the right answer. Okay, so now we're going to talk about estimation and division. When we estimate a division problem, we use something called compatible numbers. So those are going to be the numbers that you change your dividend and divisor to make solving the problem and estimating it a little bit easier. So for this problem, I might say, well, 17 is about 20. So I'll make that 20. And 9 is pretty close to 10. So those will be my 2 compatible numbers. And then I'll estimate the quotient using those. So I'll say 20 divided by 10 is 2. The idea behind using compatible numbers is that it's going to make your estimation easier. So I can use another set of compatible numbers too. I could say, well, what if I keep 9 the same, recognizing that 18 is close to 17 and also divisible by 9. So I would estimate that again with the 2 compatibles of 18 and 9 and get an estimate of 2. So when I get that estimate, I'm going to compare what I've gotten to my quotient that I found before, because we did this problem first. Before we got an answer of 1.9 as our quotient. So now we can check to make sure that our answer does in fact make sense. So I can say, is 1.9 about equal to 2? And the answer is yes. So there's a good chance that I did my division correctly, because the 2 are similar. So like I said, why estimate? So we can check our answer. So for this, I'm going to have you guys try. So for first part, I want you to estimate using compatible numbers. And then second, you're going to solve for the exact quotient using long division. Remember, when using long division, you're going to move your decimal point straight up. So you guys have a chance to pause this, and once you're done, press play and we'll go through it together. Okay, so for our compatible numbers, I might say, well, 65 is pretty close to 60, and 31 is pretty close to 30. So I would estimate that my answer will be just about 2. Just keep in mind too, with compatible numbers, they don't have to be the same. So if you didn't use the same compatible numbers as I did, that's fine. But just to make sure that your answer was probably somewhere around 2 for your estimate with your compatible numbers. Now let's go through finding the exact answer. First, we're going to look at 65. We're going to say, how many times can 31 go into 65 without going over? A little bit of thought. 2. So we're going to take 2 times 31. And for that, we get 62. And then we're going to subtract 62 from 65. So 65 minus 62 gives us 3. We notice that we still have a number in our divisor, so we'll bring that down. We have 31. So we ask ourselves again, how many times does 31 go into 31 without going over? The answer to that, it goes in 1 time. So 1 times 31 gives us 31. We subtract those and get 0. So now we're going to look. We have 0 down here, and we have no more digits left in our dividend. So now the long division portion of our problem is done. So now we're going to look at where our decimal point goes. And because this is division, remember, we bring it straight up. So we get our final answer of 2.1. So now we're going to check. Is 2.1 similar to our estimate? The answer to that is yes. 2.1 is close to our estimate. So we can think that it's probably pretty close. We probably got the right answer. If you're unsure about where to put the decimal point, checking to make sure that your answer makes sense with your estimate will help a lot. For example, if you didn't put your decimal point in the right spot, if you put it here, you'd look and say, well, 21 is not close to 2. I must have done something wrong. So it's a good way to check that your answer is correct. You have the decimal point in the right spot. And that is all we have for our first part of division of decimals by whole numbers.